Dear students, welcome to the session. In this discussion, we are going to see how the distributed databases work and the client-side architecture used in the distributed environment. Let us understand the term distributed database. To understand what is distributed database, we first revise the definition of a database. What is a database? For example, a database is a collection of logically related data that works on a single computer, right? Now, when we distribute the different parts of a database over a network, then it becomes a distributed network, as simple as that. And how do we define it? We define it as a multiple network computers can execute a transaction in a unified manner. Now, we are talking with terms of a transaction. Here, the distributed database, also called as DB, it's database. DB stands for database, and the first D stands for distributed database. What does it do? It does process a single transaction in a distributed manner or multiple transaction in a distributed manner. What do we mean by this? We mean that because the distributed database is a collection of multiple logically related databases which are kept on different computers which are connected through a network in a distributed fashion. It has a software system that will manage this distributed database while making the distribution transparent to the user. For example, if we try to use the Gmail server will be somewhere in the world. But for me, it feels like that I have all the emails stored in my account as if they are coming from my computer. So the location where the server has kept these files is transparent to me. The distributed databases does that. It actually runs the database over different computers which are connected through a network. It also has a distributed DBMS software that will help the work to be done or the transaction to be run on different places while being appearing to the user as if the transaction is running in his own machine. But the parts of the transaction is indeed distributed on different computers which are connected to the network. With this, we have come to know that there is something called as a distributed database which runs with a distributed DBMS. And there is something called as a location transparency, wherein the user will not know where the server is or where the database is stored. Rather, he feels that it is there in these two things are present in his own machine. So I hope you understood. Now let us see how does it look. For example, we have site 5, we have 4, we have site 1, 2, and 3. The database is distributed in different sites and they are connected through a network. So these are the different database system architectures. Okay. So this one is a shade, and the second one, the C, a truly distributed database architecture looks like this. We have site 1 connected to the communication network, site 2 connected to the communication network. Now the user, if the user is working on the site 3, he can access this data stored inside site 1 because it is connected to the network. Okay, so we come to know about the location transparency. Now let us see what are the advantages of distributed database system. The advantages include management of distributed data with different levels of transparency, which means that the physical placement of the files and the tables and the database, etc., or any database object is not known to the user. He doesn't know that the file I'm trying to access is stored inside my machine or inside site 1, which is, connected through the communication network. So the distribution, this is called as the user distribution transparency or location transparency. The other advantage here, the other example for the transparency is given by this figure. We have a communication network which is connecting the company's New York branch and Atlanta branch and Los Angeles branch and San Francisco and Chicago. All these branches of the company are connected, and the employees table is split horizontally, means the rows of the employees table who are working in San Francisco, or whose project is in San Francisco, or who belongs to San Francisco, are stored inside this table. Whereas employees who are working in Chicago, or projects or works on Chicago, are stored inside this computer location. Similarly, they are divided based on the New York, in the New York branch. Now here, the employee project and work on tables may be fragmented horizontally and stored with possible copies as shown below. For example, if you have a very big table wherein we have employees coming from different locations, so what did we do? We have divided that table based on their locations into their respective branches. So, for example, if an employee working in a Riyadh bank is working in a Riyadh branch, or Al Hassa branch, or in the Dammam branch, will now belong to only that branch table. So what is the advantage here? Now, if I want to access or search an employee working in the Dammam, I will go into the Dammam headquarters branch table and I will search from there. So the search process will be easier. Moreover, it will be easy for me to manage this distributed table, which is actually distributed based on a condition called as employee location. And in turn, all of them are connected through the communication network. Now, let us understand the distribution and network transparency. User do not have to worry about operational details with respect to the location and with respect to the naming transparency. Now, let us see what is location transparency. It means that it refers to the freedom of issuing command from any location without affecting its work. For example, I can sit in Al Hassa and still access the employees stored inside the Riyadh branch. Okay, so location transparency. I'm not aware where my emails are stored, which server my Yahoo emails are stored, or Gmail emails are stored. They are totally hidden from me. For me, I'm just accessing it in a very easy way. And I think that, for me, it appears that they belong to my computer, or they are stored in my computer. Then there is a naming transparency. What does the naming transparency do? It will allow access to any names object. For example, it will allow me to access any file or relation, etc., from any location. So, for example, for me, I'm not bothering that the file that I'm trying to access. If I have the name, I'm just trying to access the file, and I'm not bothering that it is coming from which branch or which site exactly. Now, there's something called as replication transparency. What does it do? It allows to store copies of data at multiple sites. So the copy of the data is like, for example, here, the copy of the data belonging to San Francisco is stored inside the San Francisco branch. So the data from the bigger table, a part of the table, which is coming from the big employee table, is replicated here. Similarly, the Atlanta employees part of the table is replicated in the Atlanta branch, and so on. This is called as replication transparency. Fragmentation transparency means it allows to fragment. Fragment means dividing. So it will allow to divide a relation horizontally or vertically. How is that possible? When you divide a big table based on the rows, then it is called as horizontal fragmentation. But if you divide a table based on the columns, then it is called as vertical fragmentation. We will see the examples shortly. The other advantages include increased reliability and availability. Increased readability and availability. Now, what do we mean by sorry? Other advantages include increased reliability and availability. What do we mean by reliability? It refers to the system uptime, lifetime, working time. That is, the system is running efficiently most of the time. Availability is the probability that the system is continuously available, whether people are using it or not using it during an interval. Okay, so reliability is the uptime where the system is running efficiently almost all the time. For example, in the night also the banner should run efficiently. Availability means that the system should be accessible during the weekends also. A distributed database system has not a single node, it has multiple nodes, multiple computers. If one fails, the other is available to do the job. So this is the main benefit of a distributed system. If I have, like for example, many branches working with my distributed database system, if Chicago headquarter fails, I have the data available, on my master computer or the server, which can take over and can do the work. Similarly, if one side is not working, the other side can solve the job of it. Improved performance is one of the advantage. Again, one of the advantage because the data fragments are, because here we have many computers doing the work, right? So the performance is improved. A distributed DBMS fragments the database or the distributed DBMS divides the database to keep data closer to where it is needed most. For example, all the employees of Riyadh Bank will be stored inside the Riyadh branch. So if I have to search or access any employees in Riyadh Bank, I will just go to this branch, or this branch is having only relevant data to itself. So the performance of searching or accessing is improved, which will reduce the data management also and the modification and the time access time also. Easily now the one more advantage is that it can be easily expanded or scalable. What does it mean? It means that the new nodes or computers can be added anytime without changing the entire configuration. So new nodes can be added anytime easily. Now let us talk about data fragments in detail. When we are splitting a table or dividing a table into logically related and correct parts, then it is called as fragmentation. There are two types of fragmentations: horizontal fragmentation and vertical fragmentation. If you have a table and you divide the table based on the columns, then it is called as vertical fragmentation. And then you store one part of it in one side, another part of it in another side, and the rest part of it in another side. Now, because the vertical fragmentation involves dividing the columns, each column have to be attached with the ID in order to have, the data distributed in a related manner. For example, in the side one, I want to store the names. So I will store the names column with the ID. Similarly, in the side 3, I want to store the gender of the employees. Then I am going to have the column of gender connected with the ID. For example, if I want to see the gender for the first employee, then the gender of the gender of, for example, John. So how will I get connected with the this table? I will use the John ID, 2, and then I come here in the gender table, and then I will go to the second ID, and then I will find out that he is a male. It is also possible that one of the side can have the complete or data. Right? I hope you're understanding. This is an example of a vertical fragmentation. Now let us see what is a horizontal fragmentation. If we are dividing the table based on a condition or based on the rows, then it is called as a horizontal fragmentation. For example, this is the data inside the employee table, and I am dividing it into rows, and I am storing rows inside each site. For example, first two rows or couple of rows are stored inside site 3. And then I store the third record inside 2, and then I store the remaining inside 1. So this is an example of horizontal fragmentation. Now, when you have a combination of vertical fragmentation and also horizontal fragmentation, then it is called as a hybrid fragmentation. Okay. For example, if I have now, for example, a combination of both, this is the part of it. Again, if I divide it into rows in the side 3 in the vertical fragmentation, if I apply horizontal over it, then it becomes hybrid because it is going to be the collection of vertical and horizontal together. And how do I do that? For example, here I have one, vertical fragment, and over it, I am again dividing it into, for example, multiple rows division or rows fragments, then it becomes a hybrid. Similarly, this can horizontal fragmentation can also have a vertical fragmentation over it. So, details about vertical fragmentation. We discussed this. Horizontal fragmentation. Okay, now let us see what is an example given here. Consider the employee relation with the selection condition as 5. So all the records that satisfy this condition will create a subset which will be a horizontal fragmentation of employees relationship. The selection condition may be consisting of several conditions connected by and or or. Now, derived horizontal fragmentation is the partitioning of a primary relation to other secondary relations which are related with the foreign keys. So here, this is our primary relation, which is divided into smaller secondary relations. Okay, and they can be connected together to get back the complete original data. Okay, now derived horizontal fragmentation. This is an example of a simple horizontal fragmentation. Now, derived fragmentation means that the primary relation partitioning of the primary relation into smaller secondary relations, which are again connected by the foreign keys, is called as a derived horizontal fragmentation. We discussed that the hybrid fragmentation is a combination of vertical fragmentation and horizontal fragmentation, and this is achieved by selection and projection together. Okay, so yeah, that this is understanding mixed hybrid fragmentation is enough, and let us not get into the details. Fragmentation schema, a definition of a set of fragments, horizontal or vertical or horizontal, which when joined together gives or reconstructs the complete whole original table, is called as a fragmentation schema. It can be done by using sequence of unions and union operation or outer join operations. Now, the way we divide the fragments over different sides is called as allocation schema. It can be fully or partially copied or partitioned. Okay, it can be fully or partially replicated or can be partitioned. This is called as allocation schema. Now let us see what do we mean by data replication. Data replication means copying of data. Database is replicated to all the sites. Okay, the database is copied to all the connected sites over a network. In full replication, the entire database is copied in, and in partial replication, only parts of the database is replicated to some sites. Data replication is achieved through a replication schema. How do we do the data distribution? We follow the data allocation schema. This is relevant or this is important only in case of partial replication, because if it is a full replication, we copy the full data, right? But if it is partial, then we are going to divide the parts. For example, I want to divide the employees of Riyadh Bank in Riyadh. So I have to distribute Riyadh employees to Riyadh branch, Dammam employees to the Dammam branch. So this is useful, or data allocation is useful only when we have partial replication or part of the data needs to be copied in each branch and not the whole. The selected portion of the database is distributed to the database sites. Now, let us see what are the different types of distributed databases. Homogeneous and heterogeneous. What do we mean by homogeneous? When all the sites, for example, here we have site 1, 2, 3, 4, 5. If all of them are having same type of database, then it is called as homogeneous distributed database system. Although the sites may have a different operating system or a different underlying operating system, but this doesn't matter to us. What matter to us is the database, and the databases in different sites are same. So it is called as homogeneous. It can be Oracle, then all of the sites will have it Oracle. If it can be DB2, then all the sites is going to have DB2. Heterogeneous means, now let us look at the figure here. We have site 1, it is having hierarchical data model. Site 5 is having relational data model. Here we have object-oriented data model, and here we have network DBMS. All of them are connected. Okay, and they are connected through a communication network. The underlying operating system is also different. So this is called as heterogeneous database. Heterogeneous distributed database, rather. Now, in heterogeneous distributed database also, we have two types. One is called as federated, another one is called as multiple database. Let us see what do we have in federated heterogeneous database. Each site may run different database system, but the data access is managed through a single conceptual schema. The conceptual schema is same, the database is different. This implies that the degree of local autonomy is minimum. Each site must follow the centralized access policy. There may be a global schema which is shared by all the sites. Okay, so we have only one conceptual schema, and I give the flexibility of my different branch to use their own choice of database, but they have to follow my conceptual schema only. In this case, the conceptual schema becomes the global schema. Multiple databases. Now here there is no one conceptual global schema. Rather, the data base the schema is constructed dynamically as needed by the application software. What do you mean by this? In multiple databases, there is no one conceptual global schema. For data access, a schema is constructed dynamically as needed by the application software. So in federated, we share the conceptual schema in multiple database. It is constructed as and when needed by the application. So it is not common for all. Let us understand the different types in more detail. Federated distributed database management have some issues like difference in data models. Yeah, because we saw that the data models are different here. Difference in constraints. Each site may have their own data accessing and processing constraints. So this is again an concern. Differences in query languages. One branch may use SQL, one may use some another SQL 92, and so on. So that was all about the distributed data bases. Now let us see how to take care about concurrency control and recovery of the database in the distributed database environments. Distributed DBs encounter a number of concurrency control and recovery problems, which are not present in centralized database. So now we have new concurrency concern issues. Some of them are listed below. Dealing with multiple copies of data item is an issue. Failure of individual sites is again a problem. Communication link failure becomes a very big problem if the network which is connecting different databases is down. Then the sites will not be able to communicate, and I will not be able to access the employees that are stored in a different fragment as per the location. In the distributed databases, we might need a special version of commit, which is called as distributed commit. And the deadlock will also not be any more simple, they will become a distributed deadlock. Now let us see each one of them. Okay. Dealing with multiple copies, how to deal with multiple, no, what do we mean by dealing with multiple copies of data item? The concurrency control must maintain a global consistency. Likewise, the recovery mechanism must recover all the copies and maintain consistency after recovery. Okay, so the data item must be consistent. For that reason, we have to maintain a global consistency. Failure of likewise for the recovery as well. Failure of individual sites. Database availability must not be affected due to the failure of one or two sites, and the recovery scheme must recover them before they are available for use. Communication link failure. The failure may create network partition, which would affect the database availability, even though all database sites may be running. Because the network is having issue, still we are not able to communicate with different sites. Distributed commit. A transaction may be fragmented because we know that the transaction can be divided and they may be executed. For example, if there is a very big transaction, it can be divided into different parts and each side can execute its part of transaction. So we need to have commit taken care at different locations or different sites in a very systematic manner. This would require a 2 or 3 phase commit approach for any transaction to commit. Distributed deadlock. Since transactions are processed at multiple sites, 2 or more sites may get involved in a deadlock. Hence, the resolve or the solution should also be done in a distributed manner. Now, let us see the distributed concurrency control based on a distributed copy of a data item. We have a technique called as primary site technique, wherein a single site is given or chosen as a primary site, which serve as a coordinator for all the transaction management. So you have, for example, site 5, 2, 3, and 4. So site 5 becomes a primary site. So this becomes as a coordinator in managing the transactions. Transaction management, concurrency control and commit are managed by this primary site then. Two-phase locking, in two-phase locking, this site manages locking and releasing the data items. If all the transactions follow two-phase policies at all the site, then serializability becomes guaranteed. Okay, so we talk about we are talking about maintaining a consistent data item. So one of the site becomes the primary site and act as a coordinator, and it will take care about the two-phase commit, and also it will take care about locking and unlocking the data items. Now let us see what are the advantages of transaction management here. The trans an extension to the centralized two-phase locking, so the implementation and management becomes more simpler. Now, doing the work by using this primary side gives us an advantage of extending the centralized two-phase locking so that the implementation and management becomes more simpler. Data items are locked only at one side, but they can be accessed at any other side. Okay, so whenever there is a lock needed, for example, at site 4, the data item is locked in site 4, still the data item can be accessed in another places. And who is taking care about doing that? The primary side is taking care. Disadvantages, all transactions management activities go to the primary side, which is likely to overload site. Now, all the job of maintaining the logs and and committing the transactions are done by the primary side. So it is high possibility that the primary site can go overloaded. If the primary site fails, the entire system becomes inaccessible. To help recovery, a backup site to help recovery, if sometimes the primary site goes off, then the backup site is chosen, which behaves as a shadow for a primary site. In case of primary site failure, backup site can act as the primary site. So if there is any problem here at the primary site, or the primary site stops working, then the site one can be made as a backup site, and now it will act as the primary site. So this is one of the way. Okay. Yeah. Now let us see what is primary copy technique. In this approach, instead of a site, the data item is divided and designated as a primary copy. Now, to lock a data item, just the primary copy of the data is locked. Advantage here, since primary copies are distributed as various sites, a single site is not overloaded with locking and unlocking requests. Okay. Now, what is the disadvantages? Identification of a primary copy becomes complex. You will not be able to identify, because the copies of data, for example, let us look at it. So, for example, here, if I'm working on data item X, then the data item X is copied here, copied here, copied here, copied here, and copied, in the primary site as well. Now, here, if I'm working, I will lock the primary data item. Still, it is being accessible by other sites. Now, what will happen here? What is the benefit? Now, because I am locking the data item here itself, in this site, the primary site doesn't have to lock and unlock it, because I am myself taking care about the data item which I need to lock. So I will unlock it. So if the same has to be done in different sites, the primary site is going to save the job for locking and unlocking for a data item which is available at the different site. So this way, the job of primary site is reduced by taking care of locking the data item by ourselves in this specific site. But the problem here is the because there were so many copies available in all the sites, identifying which one is the primary copy becomes complex. A distributed directory must be maintained. A distributed directory must be maintained, possibly at all the sites. Okay, so here a distributed directory. So we make a directory. We make a diary wherein we write that, which site is having what data items inside it. So a directory needs to be maintained. Recovery from a coordinator failure. In both approaches, a coordinator, who is the coordinator here? The primary site. So, in both approaches, a coordinator site or a copy may become unavailable. This will require the selection of a new coordinator. So, this is again a problem. Primary site approach with no backup site will abort and reset all active transaction at all the sites. Elects a new coordinator and initiates the transaction processing. This is another issue. Primary site approach with backup site will suspend or stop all the active transactions, designates the backup site as the primary site, and identifies a new backup site. Primary site receive all the transaction management information to resume the processing. So this will happen when the primary site approach with the backup site. Primary and a backup site will fail, or no backup site. This is one of the other one. Wherein we use election process to select a new coordinator site. So basically, we are trying to see how to recover when the coordinator fails. We can make a primary site approach with no backup site, primary site approach with backup site, and primary and backup site fail or no backup site. So these are the different possibilities. If we want to control the concurrency based on voting, then there is no primary copy of the coordinator needed. We will send the lock request to the site that we will send the request lock only to the site that have the data item. If the majority of sites grant lock, then the requesting transaction will get the data item. Locking information is given as grant or denied Okay, locking information, which can be either granting a lock or rejecting a record or lock, is sent to all the sites to avoid long wait. A timeout period is defined. So, if the transaction is waiting for a long time for a particular data item, then the timeout period is defined. For example, a data item cannot be logged for more than 2000 nanoseconds, for example. If the requesting transaction does not get any vote information, then the transaction is cancelled. So this is how the concurrency is controlled based on voting. Now let us see the client server database architecture. In the client server database architecture, the client runs the client software and the server provides the services. The database functionalities and the reliable communication infrastructure is provided by the server. For example, we have a server 1, 2, and so on, and different clients can request the server. Client 2 is actually making requests to server 1 and server 2 and server 3. So the clients can make the request, server provides the services to solve the request. The client runs the client software. Client server architecture in more detail. Client reach server for desired services, but the server does reach clients. Server does not reach client, for example. Sorry. So here there's a mistake. Client reaches the server for desired services, and the server provides these services. The server software is responsible for local data management at the site, much like centralized DBMS. The client software is responsible for most of the distribution functions. The client software is responsible for most of the distributed work. The communication software manages the communication between the client and the server. The processing of SQL queries is done in the following way in client server architecture. Client parses a user query and decomposes or divides it into number of independent subqueries. Each subquery is sent to appropriate server for execution. Each server processes its query and sends the result back to the client. Then the client will receive this result from different servers and finally combines the result of many subqueries and produces the final result. Okay, so this is how the job is done in, or the distributed work is done in the client server database architecture. So we have covered distributed database concept, we have covered data fragments, replication and allocation, we have covered types of distribution databases, we have covered concurrency control and recovery, and we have covered three-tier client server architecture. So this is going to be there in your exam. Thank you.